Bismillahirrahmanirrahim. Thermal breakdown. Okay, so we have started different theories, breakdown theories of the solid dielectric. So we have discussed few of them in the earlier class, like intrinsic breakdown or ionic breakdown, and we have then discussed the electromechanical breakdown, and now it's a term of thermal breakdown. Thermal breakdown. Okay, when an insulating material is subjected to an electric field, the material gets heated up due to conduction current and dielectric losses due to polarization. The conductivity of the material increases with increase in temperature, and a condition of instability is reached when the heat generated exceeds the heat dissipated by the material and the materials break down. So the various heating curves corresponding to different electric stresses as a function of specimen temperature are as follows. So there are three curves given, okay, and E3 is the electrical stress, which is greater than E2, and that is greater than E1. So we can see that greater is the temperature, greater will be the electrical stress. Okay, so more will be the chances of breakdown. Okay, the thermal instability condition is shown in the following figure. Let's suppose we have the heat generated curves are these two, E1 and E2, and the heat loss is given by a straight line, means a linear curve. So we can see that here the heat loss is shown by a straight line, while the heat generated at fields E1 and E2 are shown by the separate curves. At field E1, breakdown occurs both at temperature TA and TB, because you can see that this line crosses both of these 2 points. In the temperature region of TA and TB, heat generated is less than the heat lost for the field E2. Hence, the breakdown will not occur. Okay, so you can see that the E2 is less than the E1, so the breakdown will not occur in solid dielectric by the thermal breakdown phenomena. Okay, so now electrochemical breakdown, as the name revealed, that it's a phenomena of electrical effects and the chemical effects. Okay, at the start of the dielectric we can studied that some good characteristics of the dielectrics. So one of them was the that the insulator, a good insulator should be chemically inert. Okay, if it undergoes any reaction, so it may lose its insulation property, and the dielectric strength will definitely be less, so which is unacceptable. So for a good insulator, the insulator must be chemically inert. So if it undergoes a chemical reaction, so what will happen actually? So we will discuss this in electrochemical breakdown. So whenever cavities or the holes are formed in solid dielectric, the dielectric strength in these solid specimen decreases. Okay, because the water droplets and the humidity, uh, which absorb in these porous cavities of the solid dielectric, which will result in the breakdown of the solid dielectric. So it is also related to the thermal breakdown. In the presence of the air and gases due to the chemical reaction with insulating material, dielectric strength affected. Due to the oxidation with some air or ozone, that is rubber, is oxidized with ozone and cracks in pressure of ozone. Due to the contacts of different insulating materials with each other in any practice apparatus, due to the presence of the moisture in the water droplets, Okay, these are the reasons that why a chemical breakdown occurs. So the first one is the presence of the air in the gases due to the chemical reaction with the insulating material. Okay, the second one is the oxidation reaction, which is formed by some air or the ozone. Ozone is O3, which is formed uh, by the oxygen in the air. Okay, O2 breaks down its bond just like in the O2. Here is O2, so OO. Okay, so what actually happened? It's breakdown. So then this O ion react with another neutral atom of the oxygen. So we get it O3, which is ozone. Due to the context of different insulating material with each other, this is also the reason of the electrochemical breakdown due to the presence of the moisture in the water droplets, water particles. Okay, electrochemical deterioration is due to the presence of the mobility of the ions which are responsible for the leakage current and energy loss in the material. Okay, so these were the few factors uh, which are actually the causes of the electrochemical breakdown. Okay, now treeing and the tracking. So the name reveals that it actually shapes just like a tree, means the branches. For example, here is a hot spot, so it increases just like this. It emerges in branches, okay, and ultimately it shapes just like a tree. Okay, so that is why it is called tree effect, and that hotspot is actually occurs because of the breakdown of the solid electron. And as we know that solids are not the fluids, so the solids particles cannot replace its by the fresh particles. Okay, so the charge concentration at the voids within the dielectric leads to the breakdown step by step and finally lead to complete rupture of the dielectric. Whenever solid dielectric has some impurities in term of some gases pockets or the liquid pocket, the dielectric strength of the solid will be more or less equal to the strength of the weakest impurities. Okay, since the breakdown is not caused by a single discharge channel and assumes a tree-like structure, it is that is why known as the tree effect. Okay, the tree phenomena can be readily demonstrated in a laboratory, applying an impulse voltage between point plane electrodes with the point embedded in a transparent solid dielectric such as perspex. The string phenomena can be observed in all dielectric whenever non-uniform fields prevails. Okay, so you can see that we have already studied that we have two type of the fields, the uniform and the non-uniform. So string is actually in the category of the non-uniform fields. Okay, so here are the few glimpses for the string effect, and these are the macroscopic, the scanning electron microscopic images. Okay, and you can see that this is actually the hot spot, and this point has been broken down, okay, due to some effect, and now you can see that it spreads just like a tree and the branches. Okay, and you can see it in this figure as well, and these are the the track is actually can be shown by some numbers, that's 1 2 3 4 5 6. Okay, so it shows actually the serial number that which point actually occur first, the sequence. Then this number shows the sequence of the breakdown. Okay, okay, now the tracking, when two electrodes separated by an isolating material and the assembly is placed in an outdoor environment. One contaminant in the form of moisture or dust particle will get deposited on the surface of the insulation and leakage current starts between the electrode through the contaminants, say moisture. So the current heats the moisture and causes breakdown in the moisture film. These small film then acts as electrode and sparks and drawn between the film. The spark causes carbonization and volatilization of the insulation and lead to formation of the permanent carbon tracks on the surface of insulation. The tracking is a formation of a permanent conducting path using carbon across the surface of the insulation. Okay, now the partial discharge, as the name reveals, that it's not a complete discharge process, rather it's a partial breakdown. Okay, so partial discharge are defined as the internal discharges which causes the breakdown of the voids or the cavities or the gaseous pockets and which have the same effects of freeing on the insulating material. Means it spread gradually with the passage of time as the stress increases, so it also spreads and starts from the point, then leads to the partial discharge and followed by the complete discharge. When voltage are applied due to the capacitance action, charges are induced in the wires. Voltages due to the electric field are developed in the wires. When the voltage of the wires reaches the breakdown strength of the wire material, then the breakdown will occur. So this is the condition. This is the condition for occurring the partial discharge. Okay. Effect of the partial discharge. The effect of the partial discharge on the insulating material is the same as that of the string. During the partial discharge, charges are induced in the wires. The charges particles have sufficient energy to break down the chemical bonds of the dielectric specimen. During the discharge, heat is generated. The heat carbonizes the material of the specimen in contact of the void and thus causes the erosion. Okay, so the chemical degradation and with the result thickness of the insulation is reduced because the erosion occurs. So erosion means slowly and gradually the material will be eaten and the thickness will be reduced because of this chemical degradation, and ultimately a breakdown will occur because if the material is no more available, then it definitely means that the dielectric strength of that material will be lowered and ultimately leads to the complete breakdown. Okay, so partial discharge is more or less same as the string effect. Okay, so that was all about the breakdown theories of the solid dielectric. Okay, so we have studied the thermal breakdown, then the electrochemical breakdown, and the string. Okay, and then the tracking effect, and then the partial discharge. Okay, so the partial discharge, the equivalent circuit for the partial discharge can be represented by a capacitor. Okay, this capacitor actually shows a void. For example, this is an insulator. Okay, and if we have a void, so this portion shows one plate and this shows another plate. Similarly, this shows one plate and this shows another plate. So the electrical equivalent circuit of this void will be just like this. Okay, we have two capacitors in series. Okay, C1 and C2. This is actually the mm, electrical electrical equivalent circuit of this void. Okay, so more are the voids, greater will be the chances of partial discharge because the hot spots will occur and it will reduces the thickness of the insulation and ultimately goes to a complete rupture or complete breakdown. Okay, So that was all about the breakdown theories of the solid dielectric, and thank you for the moment.